Hello everyone. Today the world is moving towards digitalization at a very rapid pace. Almost all the areas are innovating and digitalizing. The education is just one of them. We are a group of computer engineering undergraduates from University of Ruhuna and we are presenting conference paper titled Personalized Engineering Education Model Based on Artificial Intelligence for Learning Programming. Let's dive into a quick overview of this research paper. This proposes an AI-driven model to personalize programming education. So, moving on to the next slide. This paper, authored by Abhiraj Singh Rathod, Adarsh Sharma, and Masood Masoodi from Delhi Technology University in India and Harvard University in Afghanistan. Their work focuses on using AI tools like Bayesian network and chatbot to adapt learning to each student's needs. This work was published in 6th International Conference on Computing, Communication and Security 2021, and it addresses a critical gap in how we teach programming to engineering students. Moving on to the next slide, why is this research paper important? Traditional education often treats all students the same, but we know everyone learns differently, especially in programming, where hands-on practice is key. Current systems are either too rigid or lack interactivity. For example, a beginner might need step-by-step guidance, while an advanced student needs complex challenges. The authors were motivated by AI's potential to bridge this gap. Their solution, tools like flowcharts to visualize code and chatbot to answer doubts instantly. Plus, they noticed a disconnect between academia and industry. Many graduates struggle in jobs because their training isn't practical. This model aims to fix that. Moving on to the next slide, what does this model aim to achieve? First, it classifies students into 3 levels, beginner, intermediate, or proficient, using Bayesian networks. This ensures tailored lesson. Second, it offers interactive tools like AI chatbot and flowchart generators to make learning engaging. Moving on to the next slide, it builds a bridge between education and industry companies. Companies can track student progress and even hire them through integrated tests. Finally, it boosts critical thinking by adapting feedback. For example, giving beginners detailed hints while challenging experts with open-ended problems. Imagine a system that grows with you like a personal tutor. That's the vision. Moving on to the next slide, why should we care? Because this isn't just about better grades, it's about preparing students for real world challenges. For educators, it's a tool to teach more effectively. For students, it's a personalized path to mastery. For industry, it's a pipeline of job ready talent. And the best part, this model isn't limited to programming. It could transform how we teach math, engineering, or any skill based subject. In a world where AI is reshaping everything, this research is a step toward smarter, more inclusive education. To sum up, this paper offers a future where education adapts to you, not the other way around. It is a blend of AI, interactivity, and real world realness. I'll now pass the mic to my colleague who will delve deeper. Thank you.
Thank you, Telana. I'll now explain the related work and walk you through the core system design. Earlier educational systems laid the foundation, but many had limitations. The CAI, Computer Assisted Instruction System, offered basic tutoring. However, they lacked personalization. Every student received the same content regardless of their learning level. Later, Intelligent Tutoring Systems, ITS, introduced some adaptation, but these systems were still limited in providing visual support and topic-specific feedback. Domain-specific tools such as SQL Tutor and JITS try to guide learners through programming concepts. However, they did not evaluate topic-wise proficiency, making it difficult to tailor content based on the learner's strengths and weaknesses. However, this model addresses those gaps by providing fine-grained topic-level assessment, so student understanding is measured per concept. Visual tools like flowcharts to support more effective learning, and adaptive learning content which adjusts based on individual student performance. Moving to the next slide. Now let's look at the model architecture. This model consists of three main concepts: user interface. It's interactive and organizes topics by skill level. This makes it easier for students to navigate through content and matches their current understanding. Second, adaptive feedback system. This component evaluates the student profiles and quiz outcome to provide real-time tailored feedback. Third one, database. It stores all critical data, including student progress, topic content, flowcharts, and quiz result. This enables the system to continuously adapt to each learner over time. Moving to next slide. Let's now explore how a student interacts with the model. Everything begins with the diagnostic test. The results are analyzed using a Bayesian network, which classifies the students' proficiency at the topic level. Based on their performance, beginners are provided with videos, notes, and hints for earlier understanding. Intermediate learners receive moderate level questions and guided flowcharts. Advanced learners face challenging quizzes with minimal support, allowing them to apply their knowledge independently. After each quiz or interaction, the model updates the learner's profile, refining future recommendations. That concludes the system's core functionality and flow. Over to you, Hasini.
Thank you, Tashara. Now I'll talk about one of the most important features of this system. So let's move. Learn by code can be hard, especially for beginners. So this system includes a flowchart-based tools that help students to understand how progress works step by step. What's great is that this tool gives different types of help depending on the student's level. Beginners get simple problems with full flowcharts so they can follow along easily. Intermediate students get flowcharts that are partly filled in with hints to guide them. Experts get harder problems with just basic shapes and fewer hints so they can test their skills. This way, every student gets the right kind of challenge, not too easy or not too hard. Also, if a student can't solve the problem, they can check the full solution and compare it with their own answer. This helps them learn by doing and seeing their mistakes. So, move to the next slide. The next important feature is the AI chatbot. This is like virtual assistants that available anytime to help students. If a student is stuck or confused, they can type a question into the chatbot. Then the chatbot uses natural language processing to understand what the student is asking. Then it gives the hints, answers, or directs them to helpful material. If the chatbot doesn't know the answer, it sends the questions to the real teacher. Once the teacher replies, the answer goes back to the student. This way, no one is left without support. Also, the chatbot keeps learning. If it finds a new problem and solution, it stores it in the system for future use. So, the more it's used, the smarter it gets. Let's move. Industry integration. Finally, the system also connects students with real industry opportunities. So those companies can access students' progress and see who is doing well. They can create tests inside the platform to find good candidates. These tests are monitored using webcam and microphone to avoid cheating. If a student does well, the company can contact them for an internship or even a job. This is a big advantage because students don't just learn in programming, they also get the chance to work in real companies and apply what they have learned. It also helps companies hire skilled programmers they can trust because they have already seen their performance in the system. This is about industry integration. So over to you, Dhan.
In this study, the researchers designed an AI-driven adaptive learning system tailored for programming education. The core of the methodology lies in Bayesian network model, which analyzes student performance through a diagnosed quiz and dynamically categorizes them into beginner, intermediate, or expert level, not just overall, but topic-wise. Based on this classification, the system delivers personalized learning path using curated content such as interactive flowcharts, video lectures, quizzes, and guided programming exercises. A multi-agent architecture powers the flowchart development tool, enabling students to visualize algorithms and logic effectively. Additionally, an integrated AI-based conventional chatbot provides real-time support, enhancing the learning experience and reducing dependency on instructors. This methodology ensures granular-level personalization, intelligent feedback loops, and promotes self-paced, outcome-focused learning. Moving to next slide. This model produces several key outcomes. First, it offers personalized learning by adapting content to each student's level using Bayesian networks. Second, it enhances problem-solving skills through flowcharts-based visual learning, helping students understand logic clearly. Third, the AI chatbot provides real-time support, making the system interactive and learner-friendly. Also, the model builds industry readiness by allowing companies to track student progress and conduct skill-based recruitment. And finally, faculty involvement ensures expert guidance alongside AI support, creating a balanced and effective learning environment. Moving to next slide. To conclude, this paper presents a full AI-based system that improves how programming is taught. It focused not just on learning content, but also on how students understand and apply what they learn. With the use of the flowcharts, AI chat, and faculty support, the model creates a complete learning environment for students. Moving to next slide. In the future, the authors plan to develop and implement this model in real learning environments. They also aim to extend the system to other subjects like database management system and software engineering using the same AI-driven personalized approach. The AI chatbot will be improved to offer smarter and more interactive support. Finally, the industry module will be enhanced to better connect students with companies for internships and job opportunities, making the system even more practical and impactful. Next slide. Thank you.